Welcome, everyone. I am absolutely thrilled to have you here for this explainer. Today, we're embarking on a mind-bending journey that starts with some of the absolute smallest biological wonders on our planet, and it scales all the way up to some incredibly deep philosophical questions. We often look at the world around us and just kind of assume that human beings hold the monopoly on advanced engineering, robotics, and aeronautics. But it turns out, the blueprints for some of our most cutting-edge technologies, well, they've been buried in the dirt beneath our feet for millennia. We're going to explore how nature, specifically seeds, seemingly invented human technology long before we even existed.
Okay, let's dive into this because the foundational idea here completely flips our normal understanding of how things work. I want you to just picture a seed falling from a tree. Usually we think of this as a completely passive event, right? It falls, it hits the ground, and it just waits. It waits for rain, it waits for the right season. We think of it as completely at the mercy of its environment. But the source material we're looking at today reveals that for many plants, this falling is literally just the beginning of a highly active, incredibly dynamic process. It doesn't just stay there, it actually goes to work.
Part 1, the self-planting seed. To see these hidden mechanics in action, we just have to look at the Geraniaceae plant family. When its seed falls, well, that's just step 1. It lands in an environment where humidity wildly fluctuates, so you've got dry days and really humid nights. And this alternating cycle acts as an invisible power source. The seed actually has these spiral appendages covered in stiff bristles. As the humidity shifts, those spirals literally coil and uncoil, turning exactly like a drill bit. Inch by inch, day by night, it actively bores itself down into the hard earth to secure a safe place to germinate. It's literally digging its own trench.
Now, what's really interesting about this is the astounding paradox here. Think about it. If human engineers wanted to build a self-burying probe to, say, send to Mars, it would require intricate motors, batteries or solar panels for electricity, and complex software just to tell it when to dig. Yet, plant engineering accomplishes the exact same mechanical perfection with zero motors, zero electricity, and zero software. The hardware itself physically reacts to the atmosphere conditions to execute a flawless mechanical task. It is literally hardware acting as its own software.
And this isn't just some fun piece of trivia, it is actively shaping modern science as we speak. Professor Ho-Young Kim from Seoul University studied this exact Geraniaceae seed and noted that this biological mechanism has directly inspired motorless robots that react to light, temperature, or humidity. Humanity is spending millions of dollars in research and development to try and mimic a capability that a tiny, mindless seed has already perfected. The plant is literally the teacher, and we are just the students trying to catch up.
Part 2, Nature's Hidden Engineering.
So, we've seen the drill, but different environments demand vastly different technological solutions. Take the exploding cucumber, which, by the way, is exactly as dramatic as it sounds. When this fruit ripens, pressure builds up inside until the tissue violently contracts. It basically acts as a biological pressure cannon, blasting seeds and liquids super high into the air. This sudden dispersal is so incredibly fast that researchers over at the Max Planck Institute actually had to use cutting-edge, high-speed cameras just to figure out how a cucumber was moving faster than the blink of an eye.
But nature doesn't just do explosions, it also entirely masters the science of graceful flight. Think of the maple seed. It's designed with this asymmetrical wing that makes it spin exactly like a helicopter blade as it falls, allowing it to catch the wind and travel for thousands of kilometers. Or look at the Alcimitra macrocarpa. It lives in these thick tropical forests where wind is super scarce, so it actually has paper-thin wings that allow it to glide through the air like a true glider aircraft, just sliding gracefully between the massive trunks of tall trees.
Part 3, Designs Inspiring Technology.
Let's see how this builds into real-world applications, because these natural curiosities are literal blueprints for cutting-edge prototypes sitting in university labs right now. Scientists looked at the exploding cucumber's launcher mechanism and used it to develop smart microcapsules that shoot out nanoparticles for incredibly precise medical delivery. Meanwhile, the aerospace department at the University of Maryland directly copied the helicopter spin of the maple seed, and their goal? To create a motorless aerial vehicle that stays aloft for long periods without an engine. We are actively lifting nature's patents to advance human technology.
Part 4, Who gave this knowledge?
This brings us to a critical juncture in the source material, the philosophical implications. The text points out an incredible correlation between harsh environments and perfectly tailored mechanical solutions. Environments like dry, impenetrable soil, a need for rapid spread, or the dense, windless canopy of a thick tropical forest are met with the absolute perfect mechanical solution, the drill, the launcher, or the glider.
Each seed has a highly specific answer to its unique environmental challenge. It's not just random biological matter in the dirt, it's a lock and a key.
Which naturally leads to the central existential question posed by our source material. Did these designs form on their own? I mean, how does a tiny speck of biological matter, with no brain, no consciousness, and no engineering degree, arrive at aerodynamic and mechanical solutions that take human aerospace engineers and roboticists decades of trial, error, and supercomputing to figure out?
So the crucial point is summarized perfectly by this logic. If human engineers have to intensely study these seeds to build robots, drones, and microcapsules, doesn't it heavily imply that the seed already possessed what humanity proudly calls invention? The advanced knowledge of torque, aerodynamics, and pressure dynamics was already right there. So the text poses the ultimate question. Who gave the seed this knowledge?
The source actually concludes our explainer by offering a theological answer to this intricate puzzle, turning to the Quran, specifically the Taha Surah, verse 50. The verse reads, "He who gave everything its creation and then guided it." The author's perspective is that these seeds didn't just stumble into these perfect designs by chance, but were intentionally guided to survive and thrive in their highly unique environments. It leaves us with the lingering, deeply provocative question posed by the text. The next time a seed falls to the ground, are we witnessing blind environmental luck or a masterpiece of guided, hidden engineering? Thank you so much for joining me for this explainer, and we will see you next time.